Directions. For the problems below, solve the given inequalities and then graph the solution on a number line. Okay, problem 1 says negative 5x is less than 15. So to solve this, I'm just going to divide both sides by negative 5. And when I do that, I'll get x. And then 15 divided by negative 5 is negative 3. And I divided by a negative number, so I need to switch the less than to a greater than sign. And then I'll go ahead and put negative 3 on the number line. I'll put a few numbers on each side, and then since there is no equal sign, we don't get to include it in our solution, so we'll put an open circle. Greater than would be all the numbers to the right, and again, if you checked our arrows, they match each other. Okay, problem 2, 3x plus 11 is greater than or equal to 6x plus 8. Once again, I would like to solve for x, so I'm going to get my x's together. So to get rid of 6x, I will subtract 6x from both sides. 3x minus 6x is negative 3x. Plus 11 is greater than or equal to 8, and then I will subtract 11 from both sides, so I'll get negative 3x is greater than or equal to negative 3, and then I'll have to divide both sides by negative 3, so I'll get x. I divided by negative, so I have to switch the way that this is going, and then negative 3 divided by negative 3 is 1. So I'll put 1 on my number line, 2, 0. At 1, I get to put a closed circle because there's an equal sign, which means I get to include it in the solution. And less than would be all the numbers to the left of 1. Right, the next one, I see the word or, which means I'm going to have two separate problems. I've got x plus 7 is less than 4, so we'll just treat that as its own problem to get rid of plus 7. We'll do minus 7, so I'll get x is less than 4 minus 7 is negative 3. And then the right side, just treat it like its own problem. To get rid of the minus 2, I'll do plus 2 to both sides. So I'll get 3x is greater than or equal to 12, and then I will divide both sides by 3, and I'll get x is greater than or equal to 4. And then from here, we just graph each of those problems. Put the word or in between there. We're going to have negative 3, I'll have 4, and I'm going to anchor it with 0 in the middle. Less than negative 3 would be an open circle. Less than would be all the numbers to the left. And then at 4, there'll be a closed circle because there is an equal sign here. Greater than would be all the numbers to the right. Right, number 4. The first thing I'm going to do, since I see two less than signs, is I'm just going to, draw lines straight down. And we're just going to kind of treat this as all of one big problem. Look at the stuff in the middle. 2x minus 4, to get rid of the minus 4, I'll do plus 4. But notice I have to do it to all three parts. Negative 8 plus 4 is negative 4. Those drop out, so I'm just left with 2x. And then 12 plus 4 is 16. I next want to divide all three parts by the 2. So I'll get negative 2. 2x divided by 2 is x. And 16 divided by 2 is 8. And then I'll just bring down my less than signs. So that's my answer. Then I'm ready to graph it. Negative 2, 8. I'll put 0 in the middle again. There'll be open circles for each of them because there are no equal signs underneath those less than signs. And then since x is in the middle, it's connected, we're going to make a connected graph. Okay, problem 5, 4x minus 2y is less than 12. I will put on this one that we're going to shade because there's a less than sign. And same thing with on number 6, we're going to shade because there's a less than sign. 4x minus 2y is less than 12. We do need to make it say y equals in order to graph this one. So I'm going to write 4x minus 2y equals 12. I really don't care that it says less than right now. I'm going to subtract 4x on both sides. So I'll get negative 2y equals 12 minus 4x. And then I'll divide all three parts by the negative 2. So I'll get y equals negative 6. Negative 4 divided by negative 2 is a positive 2x. So now I'm ready to graph it. I'm going to start down at negative 6. And then from there, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. I'm going to make it, I'm going to make it a dashed line because there's no equal sign in there, so we don't get to include it in our solution. Okay, and then I'm going to test 0, 0 right back up in the original, so I'll put zeros in. I end up getting 0 is less than 12, which is a true statement, so I'm going to shade the side of the line that has the 0, 0 on it. Okay, number 6, x is greater than or equal to 5. The x-axis is horizontal, so x equals is going to go vertical at x equals 5. And there is an equal sign, so we get to make it a solid line. And then if I test 0, 0, there's really only one place to plug 0 in. I get 0 is greater than or equal to 5. That is false. 0 is not bigger than 5. So we're not going to shade the side that has 0, 0. We're going to shade the other side.